Hey guys, what's up? Welcome back to my channel. Today we're going to go over the homework for lesson 2D-1. So I'm not sure which ones I'm going to go over yet, but you'll see. Number 2. We're going to start there. Number 2. Given an arithmetic sequence with a sub n equals 8. That's important. And a common difference, d, is equal to 2.5. Find the 22nd term. So that means you're trying to find a sub 22, and that means n is equal to 22. All right, so this is all the information that we have. A sub 1 is 8, d is 2.5. We're looking for the 22nd term, so that means a sub 22, and n is equal to 22. Remember, whatever number is here must match what n is. So a sub n is equal to a sub 1 plus n minus 1, not really sure what that was, times d. So a sub n, we know n is 22, is equal to a sub 1, we know is 8. We know that n is 22 minus 1, and we're going to multiply by our common difference of 2.5. So guys, you're just going to enter this thing into the calculator exactly as it is shown. So the value of a sub 22 is equal to 60.5. This is the 22nd term in the list, 60.5. All right. All right, we'll do number 4 next. An auditorium has 50 seats in the first row, 54 seats in the second row, and 58 seats in the third row. So this is what we're looking for. First term is 50, then 54, then 58, and so on in the same increasing pattern. Okay, so from this, I want to know the number of seats in row 30. So I'm looking for a sub 30. So that means n is going to be equal to 30. A sub 1 is equal to 50. And a common difference. What are we increasing by each time? Each row has an additional 4 seats. So we have positive 4. So you're going to plug it all into the formula. Okay, so we plugged in all the values that we have listed on the left. And now I'm just going to put this in my calculator. I'm going to put all of this directly into the calc. The number of seats in the 30th row is 166 seats. So 166 seats in row 30. Okay. Okay, so for all you period oneers, which function rule describes the arithmetic sequence below? You want to find the one that works for each and every number. So for instance, say I was testing out choice 1. F of n equals n minus 4. So that means if I wanted to test the third value, f of 3 should be equal to negative 17. Okay, so if I plug in 3 to my function, right, so see I just plugged in wherever I saw n, I plugged in a 3 for the third position, I get negative 1. Does that match up? Is the third number in the list negative 1? Nope. Now for choice 2, the third, f of 3, is that equal to negative 3 times 3 minus 6? Well, I have negative 9 minus 6. That's negative 15. Is the third number in my list negative 15? No. So I'm trying to erase this little smuts right here, and it seems like it's forever part of our lives. It's not leaving. It's not erasing. Like, Oh, just like that, it's gone. All right, so now choice 3. If this is the explicit formula or the rule, that means if I plug in 3, f of 3, if I plug in 3 for n, that means it's going to check out. So I know the third term is negative 17. I have negative 12 minus 5. Is the third term equal to negative 17? It is. So that is the answer. That's the rule. All right, you could double check. The fourth term is f of 4 equal to negative 21. Well, let's check that too. If I do negative 4 times 4 minus 5, that's negative 16 minus 5, which equals negative 21. So it does work. All right. So guys, this is a short one today. You only have to do up to number 5 if you're in period 1. Only have to do up to number 4 if you're in period 4. So hope this helped. Have a great one.